thank you for watching my video. The first thing that we'll talk about, or the next thing, and this will probably be the last video I do, is how to transform a parabola or quadratic or a function with the power of 2. And the power of 2 I'm really referring to is this one right here. So we know we have the base function, and we know that if we graphed it, it would look like this. And the base function, the origin of the base function would be centered right on top of the origin, which is 0, 0. And so if you look over here, we have the first one we're talking about is f of x equals x plus 2. And so if we really wanted to see what would happen, x squared plus 2, if we really wanted to see what happened to the base function, we can go ahead and use our calculator. And so I'll plug this in. So as you can see, I've already have our base function in the one spot there. I'm going to go ahead and delete. Then I'm going to put in x squared, not the parentheses, x squared plus 2. So I hit graph, and I see the base function, and then I see the one that has plus 2. So what happened? What was the transformation that took place? Well, as you can see, the base function is down here, and the new one shifted up 2. And so that would mean that this plus 2, okay, causes it to shift up by 2. Well, let's go over here to the green one, and I can go ahead and see. Okay, so I have this x plus 2, and so I'm going to go ahead and let's see what happens. So I'm going to plug it in the calculator. I'm going to go ahead and erase that second one, so I'm going to go ahead and just hit delete a bunch of times. I'm going to open the parentheses up. Let's see, make sure to get it right this time. Parentheses x, I put 2 parentheses. I'm not having a good time with the parentheses. And plus 2, close parentheses, and squared. So I'm going to see what happens. The base function is going to be drawn, the thin line. Yep, and there it goes. So what happened to the base function? Well, as you can see, the base function went left. It went left, and if you count the spaces, 1, 2, it went over 2 spaces. And so if you look, this plus 2 caused a shift left of 2. Now, just knowing what we know, and see, I can actually go graph it, so I'll do that. 1, 2. And if you forgot from earlier, let's see. If you remember from earlier, this shifts up 2, so we have 1, 2. Alright, now, we're going to take our reasoning over to this yellow one. And so if you look at the yellow one, so a positive 2 shifts left of 2. Then what does a negative 4 do? Well, if the positive shifts left, the negative shifts right. And so we have a shift right of 4. Okay, and let's go back over here. So at the end, we have this minus 7. Well, if you remember, anything after the x squared, so if it's a positive 2, it shifts up 2. So if positive shifts up, then the negative will shift down by 7. And so from this, just from seeing this this vertex form of the equation, we can actually do the work without actually having to ever graph the problem. And so we can say shift right 4, so 1, 2, 3, 4, and shift down 7, 1, 2, 3, 4, 5, 6, 7. We'll intersect about right there, and we'll have some line that looks like this. Okay, now, in the beginning, or in the earlier videos, I talked about the negative and what it does to the x. So when we had f of x equals negative x, what happened? Well, it flipped the line. Well, ironically, it's not much different than what happens here. So we're going to talk about this right quick. So let's go ahead and go over the things we already know. This positive 2 here is going to have the same effect that this positive 2 has, and so it's going to shift left this vertex or origin, either one, shift left 2. And this negative 4 is going to have the same effect this negative 7 did, and shift down by 4. So shift down 4. Alright, so let's go ahead and get the origin mapped. So we have the original base function will be at 0, 0. It's going to go over 2, so 1, 2, and it's going to go down 4, so 1, 2, 3, 4, and so it's going to go right there. Now, before we get carried away and go ahead and write it upward sloping, I want to draw attention to the negative. What does the negative do? Well, if you go back to our calculator and we look, we can go to our y equals, okay? We can take the base function, so the base function is x squared, and put a negative in front, so negative x squared. And we can see what happens. What does that actually do? And I'll make it bold again, okay? And we'll see what happens. So there's our base function, it's in a thin line, and our new line, our negative x squared, flips downward. And so this negative here is going to cause it to flip. So instead of it going upwards like this, okay, it's going downward like this. And I hope that at the end of this video now, I hope you kind of see how the vertex form, and let me go ahead and write out the vertex form. Let's do another color, red. We're going to highlight here that the vertex form, okay, the vertex form, this is a formal definition, f of x equals, and we'll call it x plus, and I always do the h in cursive, and the k in cursive. If you'll see, the vertex form kind of tells us exactly what the equation will look like. So I hope you enjoyed watching my video. Thank you for watching.